Okay, example D of the two-dimensional vectors. We have an airplane traveling at an airspeed of 100 miles per hour at 30 degrees south of east, and the wind velocity is 200 miles per hour due west. And wants to determine the velocity of the aircraft relative to the ground. So what we have going on, if a plane, get this up here. We have a plane that's flying with its velocity 100 miles per hour, 30 degrees south of east. So that's the 30 degrees right there. And then we have this wind pushing it 20 miles per hour directly to the west. So we need to figure out what direction and speed the plane is actually flying at. And so, of course, the way we do that is we just add those two vectors together. Again, we've got them in polar form. We need to get them into vector form so that we can use them more easily. So VP, which is the velocity of the plane, is going to be 100 times the cosine of negative 30 in the I direction, plus 100 times the sine of negative 30 in the J direction. And velocity of the wind is going to be negative 20 in the I direction with nothing in the J direction. So again, we get help by at least half of it being simple. So our velocity, which is the sum of these two, is going to be 100 times the cosine of negative 30 minus 20. These are all miles per hour. Plus 100, whoops, that's in the I direction. Plus 100 times the sine of negative 30 in the J direction. So again, we get to a calculator. (100) cosine negative 30 minus 20 from that. So it's going 66.6 in the I direction. And 100 times the sine of negative 30 in the Y direction. So it's going negative 50 in the J direction. And so that's it in vector form. But in reality, and we have to do that to get it added together. But in reality, if you're in the plane, you probably don't want to know that we're going 66 miles per hour east while going 50 miles per hour south. What you probably want to know more likely is what way are we going, what's our total velocity, and which direction are we actually going. So to do that, we have to go back and combine it back into polar form. So we want to take V into polar form. So we've done this several times. We know that the magnitude we need to get the magnitude of V, which would be the square root of the 66.6 squared plus the negative 50 squared. And we need to get the angle theta, which is going to be the tan inverse of the y part divided by the x part. So the velocity is I'm going to get the exact number for the 66.05. The negative 50 is actually exact. Again, whenever we're putting a negative number to be squared inside there, make sure we get our parentheses in the right place. So negative 66 plus 50, negative 50 squared. So we're actually going 83.3 miles per hour. And theta is the tan inverse of negative 50 divided by 66.60. Decided not to go for the... Whoops. So what happens when you take tangent instead of tan inverse? So an angle of negative 36.9 degrees. So what we're actually, our velocity that we're actually doing is 83.3 miles per hour at negative 36.9 degrees. Or we could say that 36.9 degrees south of east. And that's how we would discuss that one.